This is my homebrew 1-bit vacuum tube computer project, and actually it's my first ever homebrew computer, and I decided to do it out of vacuum tubes. At low voltage, no less. There's no more than plus 24 volts or minus 12 volts at any point on here, which means that all of the vacuum tubes are using plus 24 volts for their logic levels. And yeah, nobody said I was smart, man. I chose hard mode straight out of the gate, but after like 3 years of work, we're nearing a point where I can say that we're almost done with it. It's almost ready to work. And well, what I want to do today, well, today for you guys, it's going to be like 4 days of sun up, sun down hard work for me. But what I want to do today is get this executing its first instruction. Now we need a couple of important components for that. Like I said, it is a 1-bit vacuum tube computer, and the processor side of it is all here. That works. We've tested it with a little remote control. So this is the big question mark right now. Now, because we only have 8 bits of RAM, we have 1 byte of random access memory, this thing is not loading instructions into memory and then executing them out of memory. It's executing the instruction directly from read-only memory. And for this one, we're using paper tape as our read-only memory. The good news is that we can build the paper tape in a loop, and we can have interesting looping control to do interesting branching based upon input enable and output enable and stuff like that. And we'll get into more detail on how exactly that works once we actually have the dang thing functioning here. But we are executing instructions directly from paper tape. But how's that possible? We only have 8 bits per line of paper tape here. Well, it turns out that we only have a 4-bit instruction for the processor side here, and then a 4-bit memory address. Like I said, we only have one byte of RAM, so we don't actually need a very big memory address. So 1 byte off of our paper tape here is 1 full instruction with opcode and memory address. So all we need to do now is, this paper tape reader seems to be working pretty well, we need to get it plugged into the rest of the system. But that's not that easy. We have 2 more PCBs that we got to cut, and you can probably hear the mill out there running right now. It's been cutting PCBs for like the last 3 days straight. But this one is going to hold the halt logic. This one is going to hold some single stepping logic for debugging. And then we have a bunch of PCBs that we need to cut that connect all of the individual boards to each other. So I got a bunch of little headers here all over that need to connect to each other. So I've got a whole lot of those that I have to solder up as well. And even once we get that done, we're still not out of the woods yet, because these 2 boards are actually completely separate at the moment. I have to build a harness that connects the processor to the rest of the memory and program control over here. So we've got a whole lot of soldering to do, running wires and building a custom harness to connect the 2 to each other. And even then we're not out of the woods yet, because I still have to find some way to power the whole thing up. Talking probably over 1 kilowatt of power, because I think there's something like 350 plus vacuum tubes on this thing. I don't know, I haven't counted, but there's a lot. So we need to come up with some kind of way to power both of these machines up at once. And if we get all of that done, when we flip the switch and hit go, the paper tape should start reading and lights should start blinking and things should start happening. And that's what I'm hoping to get to today. But like I said, we have a ton of work, and a lot of it is actually kind of boring. Watching me solder PCBs is, I don't know, not that much fun, I don't think. So I'm just gonna do all that while you guys are watching the opening credits. For a bit of context, all of these little guys need to be soldered up. It's not an insubstantial amount, to be sure. I just got the Marantz bumping with the Phantom Liberty soundtrack and jammed out while I soldered everything up. There are 2 more larger PCBs that need building out too. One has a halt function and the other has toggle switches and a push button for single stepping. Unfortunately, I made a comedy of errors on both of these that's gonna bite me later. But at this time, I didn't know that, so let's get things in place. The little PCBs are literally just connectors. There's a colossal number of signals moving back and forth across this thing, and these PCBs just connect those signals from board to board. Super boring, but very necessary. Next, let's get the halt PCB and single step PCB mounted. I'll drill new holes in the backing board using the vacuum to catch the wood dust from the drill. Then I thread in the standoffs directly into the wood itself. And finally, I can hold the PCB up in place and lock it down with the appropriate machine screws into the standoffs. With both going in, it's already starting to look way more complete. But these being the last two major PCBs that needed to be built, what are they and how do they work? And I had an entire segment planned where I would just sit down here with the PCB and I'd say, this is the halt circuit and this is the schematic that I designed and here's how it works, except it doesn't work, man. I spent so much time trying to troubleshoot that halt PCB. It comes up a little more throughout the remainder of this video, but I spent just a colossal amount of time and effort trying to get that halt PCB working, and it still does not work, and I don't know why. It's driving me nuts. And so I'm not gonna sit here and tell you how it's built, because however it's built is clearly wrong. So that's something that I'll deal with in the future. Anyways, with all the PCBs in place now, it's time to build out the harnesses, starting with the small harness that goes from the phototape reader to the halt PCB. I laid out a little template and tape on the desk, then bent up each individual wire, cut it to length, and ultimately soldered it in place in the correct order, hopefully. I used a simple solid core wire here, which really helped the harness keep its shape. This is the easy harness though. It was nice and short and didn't have too many wires, and it popped into place perfectly. Now for the difficult harness, the one that connects the two backing boards to each other. You can see me stringing wire here, but more importantly, you can see my guide taped to the backing board. I most assuredly did not have the pinouts and wiring memorized, so I made up this little wiring diagram that showed all the interconnections and made it much easier to follow. Still, diagram or no, this portion of the build is just a lot of this. Stringing wire from top to bottom, bottom to top, and along the edges, and if you look really closely, you can see just how thin my hair is getting on top. I think wearing hats is going to be in my future. At any rate, once I had all the wires soldered in place, I needed to tidy the harness up, and to do that, I'm just using extra pieces of solid core wire and wrapping it around the harness itself. Ultimately, I want to go through and wire lace this harness, but I definitely don't want to do that now because I'm moderately confident I'm going to need to rip some or a lot of these wires out at some point. Once the whole thing is up and working and we're sure that the harness is good, I'll pull the harness off and lace the whole thing. Next, we need a box for long tape loops to fall into so don't get all tangled up in the tubes. And I found this piece of scrap aluminum already bent mostly perfectly. I just need to cut it a little shorter is all. A quick run with the file along the edges smooths them out, and I want these to be smooth to the touch so I don't donate too much actual blood to this project. Holding it up in place, I think right about here is going to look good. The box doesn't have a bottom though. So the first step is bolting this piece of wood into place, which will act as the bottom. I'm using L brackets here because I don't want to remove the whole thing just to run screws from the backside. These brackets will be hidden inside the box anyways, so I think it'll look all right. The box itself had two mounting holes on the side that I'll reuse and connect up to little L brackets, and the whole thing then mounts super stealthily. What's more, the box has two captive nuts on the front already. That means we can make like a little plaque that bolts into place right here on the front. And I have some ideas for that, so we'll get into that in a future episode for sure. Finally, I need to power the whole thing up, and for that I need to salvage the power supplies out of these two boxes, which were the original power supplies while I was building the machine up. And yes, I am just using some modern Meanwell supplies to power this thing. Initially, I had no idea what the total power draw would be, and designing a period correct power supply is no joke, so you gotta have all your ducks in a row. Now that we have an idea how much power it's pulling, I may in the future build an actual period correct supply for it, but first, let's just get this thing working. I'll lay all three supplies out on a piece of wood to get an idea of where they're all gonna fit. Then after cinching them down, I'll cut a piece of scrap fiberglass for the front panel and get it screwed tightly into place. Then after some hole drilling, I'll get the binding posts in place and cinched down. And finally, fueled by some Swedish fish, I'll just sit down and wire the whole thing up. After making some new custom cables and mounting it to the wall, the finished collection looks stunningly good. It's a wild mixture of Art Deco and mid-century modern, and I think this is without a doubt the coolest looking thing I have ever built. Just a beautiful culmination of 3 years of questionable decisions. I absolutely love it. All right, everything's connected. We've got power running into it. We've got all of the boards connected to each other. The only thing that's left right now is to flip the switch, and I am incredibly nervous about this. I have not powered on this half of the machine as a single unit ever. So that is a massive unknown. Also, I have no idea how any of this stuff is going to interact with the paper tape reader. I'm procrastinating. I'm procrastinating because I'm scared of it. All I want to see happen is all of the tubes warm up. The tape doesn't have any legitimate data on it. We're not expecting it to execute code. We just want to see it warm up. Here goes nothing. I hope nothing catches on fire. Well, the tape kicked off. I'm just going to go ahead and unplug that. We're going to unplug the tape. Oh. Just pop you out right quick. Did not go well. Okay, I'll zoom in and tell you what just happened. I think I might possibly have a short circuit somewhere. Look at that. Oh man, we just absolutely fried that trace. And that's like a big honkin' thick trace. So yeah, that's not good. That's obviously the 24 volt line, and that's gonna be causing all sorts of problems. So I need to bodge that first of all, and then figure out why my soft start isn't working correctly, and then figure out where the short is. So we that's awesome. After some hunting, I think I've found the issue, and it's these jumpers right here. These are primary power jumpers that are feeding the power rails from the left to right side. And I never tested these because I didn't make this connector until the very end here. And these two here are supposed to be going to plus 24, and these two here are supposed to be going to ground. I've got them routed to the wrong place. So it was 100% a routing error on my part, and it means that I was effectively shorting the plus 24 volt rail to ground directly, which is why we almost started a fire. All right, round two. I fixed the problem up there by just going out to the drill press and drilling a couple new holes, and then soldering in some new jumper wires. And honestly, I think it ended up clean enough that I don't think we need to recut that board. So I'm just gonna leave that board, if it works, I'm just gonna leave that board there. I still have the paper tape reader unplugged here because we're not concerned with data. There's not even any credible data in there to read. So I just wanna see if the filaments all come up on both machines at the same time. We're listening for 3 clicks, one from each of the 3 soft starts. So here we go. All right, things are starting to warm up. I can see some filaments lighting up. There went 1 click, I think. There went 2, 3. Oh, there we go. There was the 3rd click. I'm just hearing tubes get warm and quiet and popping. But I think everything is coming up now. I can actually see some VFDs illuminating down here. This is the output register. I think that means that all of the filaments have come on and both halves of the machine are up. And if we had good data going through here, we might actually be executing code. So I think we're okay to move on to the next step. Okay, my halt board here is still very not right. I mean, it's all plugged in and obviously nothing's running here. So something's not working right with the halt board. But I think we can get it to run by just pushing and holding the button, and that'll cause the paper tape to spin around. So let's see if anything is happening. We're obviously not going to be running real instructions, but I do want to see things like the instruction register over here blinking and flashing as incorrect instructions are clocked in. So here goes nothing. Yes! I can see it! The instruction register over here is blinking like crazy. We can see that something's happening over here. I think that means that it just executed its first instructions, though they were absolutely the wrong instructions. That's cool. But we need to get a tape going through it that actually has some meaning on it, because I think we might be able to start running stuff. This is awesome. All right, I'm really burning the midnight oil here. I've had all sorts of problems. Apparently on the facet paper tape punch, and I don't know, maybe this is the standard, but they're set up with bit 0 on the bottom of the tape and bit 7 on the top of the tape. And I have built this thing to have bit 0 on the top of the tape and bit 7 on the bottom of the tape, so it's backwards. So my test program was meaningless once it punched out because I couldn't use it. And because the clock is offset, you can't just like flip the tape over or anything like that. So after I figured out how to reverse my programs, I'm gonna have to write a script to do that in the future or something like that. I do have a little test paper punched out, but I also am having trouble with bit 6. It doesn't seem to be punching all the way through, and that's something that I didn't notice on 5-level tape because there isn't a 6th level to do that. So I had to fix the bit 6 by hand with an X-Acto blade. It's not gone well. Also, I have no idea why my halt doesn't work anymore. Like, it never works. It just seems like the thyrotrons are always conducting, and they absolutely shouldn't be. But this is a pretty short program, so I'm gonna run it by hand. What it should do is fill up the scratch register, fill up the output register, empty the output register, empty the scratch register, and then halt. Now, it's not gonna halt because our halt is broken, but if the output register is filling up and emptying like it should, we should be able to see that here. All right, let's give it a test here. I will feed the tape in, and then we will just push the button, and let's watch down here and see if anything changes. Nope, nothing changed. Ah, that's so frustrating. All right, let me think about this. All right, I'm starting to get bleary-eyed, so let's head in, spend some quality time with the bunny, and come at it fresh in the morning. And I did indeed notice something wrong with my halt circuit, another routing error, and you can see the underside of this thing is getting pretty full with bodges. Spoiler alert, this didn't fix it. So let's work on the diag panel next. The only remaining push button I can find is this one on this old project, so time to do a little bit of harvesting here. A little solder wick picks up enough of the solder and makes it nice and easy to lift the push button right out. Then I'll just solder it into place on the new diag panel. Okay, some progress. We're doing baby steps here. I can't single step it, even though I moved the toggle switch over, because single step is contingent upon the halt working, and the halt still doesn't work. I've taken like 16 swings at getting this. I don't know what it is. I built all of the rest of this, and I can't figure out 2 stinking thyrotrons. It's just, the halt circuit is gonna break me. So we're just gonna ignore it for right now. So I can't single step, but by getting the diag board here, I was able to see the VFDs here, and that illuminated that we had one data bit not working correctly. I had wired it up wrong. So I had accidentally tied that data bit to ground. So now we've got data rolling through. If I plug this in here, the tape is rolling around, and we can see the data flickering on the input VFDs here, but this also illuminates yet another problem. Half of the tape is filled and half of the tape isn't. So you can see half of the time all of the VFDs are off, except for this topmost one here. I believe this is data bit 0. We'll unplug that because it's super noisy. But it seems like data bit 0 is never going low. So we had a problem with data bit 3 down here never going high, and now we have a problem with data bit 0 never going low. But if we can figure that out, it seems like data's making it throughout the system, which is pretty exciting. Time to break out the scope. I've got the probe hooked up to the bit in question here, and looking at the scope, I can see some squiggles, but not nearly enough. Let's give the potentiometer a turn here and see if we can make it better. And yeah, look at that, coming right into spec. This makes sense. The board is in a different part of the room with different ambient lighting, so the bias is naturally going to be different. I went through and readjusted all the other potentiometers as well, and it looks like we now have clean logic signals coming through. The diag VFDs are blinking away beautifully, but how do the signals look going into the instruction register? Yeah, that's not great. But the tape is slipping quite a lot. And if I put pressure on the capstan by pressing down on the roller bearing, look at that. It cleaned right up. It's mega fast at about 5 milliseconds per pulse or 200 hertz, but that is clean looking. And let's compare the data coming into the instruction register versus the data sent. This is just the instruction portion, and we can clearly see the string of 1000 instructions, followed by the string of 1001 instructions, capped off at the end with 31111 instructions. This is the 16 store commands, followed by 16 store complement commands, and the final 3 are halt commands. And that all looks spot on. So it looks like we have the correct instructions making it all the way to the instruction register, but we're still not executing correctly, which means that we might be going too fast. And I was worried about that with this paper tape reader because I only put 1 reduction gear on it, and I should have done 2 reduction gears on it and got it down to be really slow. When I first designed this thing, I was aiming for a speed of 45 hertz, but with the way that this paper tape reader has been built, the slowest I can get it to go is like 150 hertz, and I think right now it's chugging along at over 200 hertz. So we are pushing the tube computer about 4 times faster than I ever intended it to do, and that could very well be causing a lot of problems. So I think the next step is to, first of all, solve the halt problem here. Because if I can solve the halt problem, then I can use my switch panel here to single step. And then if I can single step, I can start confirming that if the 2 sides are playing nice to each other. If they are playing nice with each other, then we can start bringing in the photo tape reader, ramping up the speed, and seeing if it's a speed related issue, if we still have something wired up wrong, or what. But this is pretty exciting. This is a project that's been going on for like 3 years, and I'm gonna say it executed its first instructions right here today. They were the wrong instructions, but that still counts in my book. So I want to thank you all so much for watching, and I hope to see you in the next episode.